The science behind the Flosure ventilation patch. How the Flosure ventilation patch works. In the previous module, optimizing negative pressure wound therapy outcomes using the Flosure ventilation patch, we learned the explanation of how the patch is used and why it is necessary to promote flow. Let's look a little deeper. Semi-permeable transparent dressings, or drapes, do not promote gaseous exchange when they are used with negative pressure wound therapy. Many of the original design elements of negative pressure wound therapy have been modified or improved over the years with the exception of semi-permeable transparent dressings, which continue to be recommended by all manufacturers. Semi-permeable transparent dressings were chosen as a regular covering over foam or gauze or other dressing mediums for a number of reasons. Its transparency allows clinicians to see what is happening in the wound bed. Its moisture vapor transmission rate properties were thought to allow gaseous exchange to promote flow, thereby facilitating the flow of exudate within the wound bed, helping to prevent maceration and infection. But this premise is deeply flawed. Semi-permeable transparent dressings function quite differently when negative pressure is applied. Let's take a look at how semi-permeable transparent dressings actually work. In Figure 1, you can see that under normal conditions, when transparent film dressings are used on any wound that does not involve negative pressure, the moisture vapor transmission rate properties allow gaseous exchange through the dressing. Here we can see how wound exudate and moisture are vaporized and exit the transparent film, preventing maceration and infection of the wound, while at the same time preventing any bacterial penetration through the film in either direction. Notice how the physical properties of the transparency provide this gaseous exchange. Very tiny microporous openings in the film create the gaseous exchange between the wound and the outer surface. Now let's observe the same dressing under negative pressure wound therapy. In Figure 2, you can see that as negative pressure is applied to create an airtight seal, the drape shrinks, contracts, and takes the form of a raisin-shaped surface. As a result of this shrinkage, the tiny microporous openings of the film close up and become blocked and occluded due to a phenomenon called vapor lock or vacuum lock. Therefore, the moisture vapor transmission rate properties of the film are negated under negative pressure. Figure 3 shows the semi-permeable transparent dressing before and after negative pressure is applied. Once these tiny holes are closed, it means no gaseous exchange or air is being exchanged in either direction while under negative pressure. Another exception to this rule occurs when there is sufficient exudate being drained from the wound bed. This drainage creates flow. However, when drainage slows and stops, the system will reach a stagnant point where the pressure at the wound site and pressure at the pump are equal. As you can see, when the pressure is equal in both of these locations, flow of fluid stops, causing stagnation in the wound bed. This is a simple law of physics and fluid dynamics. It is all about creating a change in pressure, or delta pressure, between the wound and the suction pump to help move the fluid. You have heard or read in the manufacturer's operating manual to lower the suction pump below the wound surface or parallel to the floor in order to help move the exudate. In this instance, delta pressure is created by simple gravity to help move the exudate from the wound bed to the collection canister. For negative pressure wound therapy to be effective, a pressure differential for the pump must be established in order for the pump to function continuously to prevent stagnation or blockage. This is easily achieved without tampering with your dressing protocol or moving the pump around to account for gravity pressure by just introducing the Flosure ventilation patch. The Flosure ventilation patch, when used in conjunction with semi-permeable transparent dressings, optimize the dressing protocol. By simply introducing filtered air into the wound bed to promote flow, the Flosure ventilation patch preserves the important properties of the semi-permeable transparent dressing while compensating for the occluded vapor exchange properties of the dressing under negative pressure. What we have learned. Negative pressure wound therapy is an excellent protocol for wound healing. Semi-permeable transparent dressings are still the preferred choice as a drape. The Flosure ventilation patch must be used to ensure proper airflow based on simple laws of physics. It's as simple as that.